Hello everyone, today we're going to be talking about finding the distance between 2 points. So when you're given any two different points on a coordinate plane, so let's just draw a simple little coordinate plane on the side, and let's say we're given point A and point B. Finding the distance between them is literally just self-explanatory. You're just finding the said distance. Now, of course, lines between 2 points are mostly always diagonal, so it's kind of hard to, and that's why we have a formula. So as you can see here in the middle, the formula for distance is d is equal to the square root of x squared minus x1, the whole square, plus y2 minus y1, the whole square. And that is if you're given any 2 points, x1 comma y1 and x2 comma y2. So let's try a couple of examples using this said formula. Okay, so here I've written down our first question. So we're going to want to find the distance between the point 1 comma 5 and 2 comma negative 1. So we have our distance formula up here at the top, and let's just substitute our values. So first we want to designate which one is our x1, x2, and which ones are y1 and y2. So you can take any coordinate. So this one can be x1 and y1 or x2 and y2. And the same goes for this one. It doesn't really matter which order they're in. You just have to make sure you designate them both to be the same. So for example, if 1 is x1, then 5 must be y1. It can't be y2. And if 2 is x2, then negative 1 has to be y2. It cannot be y1. But you can make this as x1 and this as y1 and then switch these as well. That doesn't matter. You just need to make sure that they're the same throughout. So let's substitute these values into the formula. So we have d is equal to the square root of x2 is 2 minus x1, which is 1, the whole square, plus y2, which is negative 1, minus 5, which is y1, the whole square. So then it's going to be the square root of 1 squared plus negative 6 squared, which is just the square root of 1 plus 36, which is the square root of 37. And over here, down here way at the bottom is our final answer, the square root of 37. Of course, you could always simplify that to 2 decimal places, but the radical form is just square root of 37. So this is our next question. We're going to be finding the distance between the points negative 1 comma negative 5 and 6 comma 2. So first we're going to want to designate our x's and our y's. So let's make negative 1 x1, negative 5 y1. This can be x2 and this can be y2. Now, just as like our last example, we're going to substitute everything into the formula. So d is equal to the square root of x2, 6, minus negative 1, the whole square. And you can see that we have 6 as x2 and negative 1 as our x1. So we're just going to subtract negative 1 and we're going to simplify that later on. So plus y2, which is 2, and again, the same thing goes. Since negative 5 is y1, we're going to do minus negative 5, the whole square. Now to simplify that, this will just become 6 plus 1, the whole square, and this will become 2 plus 5 square. So then this will simplify to 7 squared plus 7 squared, because 6 plus 1 is 7 and 2 plus 5 is also 7, which is just equal to 49 plus 49, which is just equal to this. Sorry about that. Okay, so this is just equal to the square root of 98. So you could also simplify that, as I said before, using 2 decimal places, or you can just simplify the radical form, but our final answer in this case would be the square root of 98. So this is our last example, and so we have 4 comma 6 and 4 comma negative 7. One thing you can notice is that the x values are the same, so we have 4 and 4 in both of the coordinates. If you draw this on like a simple, so let's draw a basic coordinate plane. Let's say this is point 4, this is 6, and let's draw a bit down, this is negative 7. If you draw point A and then point B, you'll see that it's just a vertical line, and finding the distance between this vertical line is just the distance between 6 and negative 7, which would be 13, because you're going 6 down to the x-axis and then 7 down as well. So it's 13 points. That's the distance. But of course, if you just want to prove this using the distance formula, you could just substitute the values as I said before. So we're going to substitute this as x1, y1, x2, and y2. This we've done for the past 3 examples, should be pretty self-explanatory. Now let's substitute everything back into the formula. So d is equal to the square root of x2 minus x1, so 4 minus 4 the whole square, plus y2, negative 7, minus y1, so negative 7 minus 6 the whole square, which is equal to 0 squared plus negative 13 squared, which is equal to 0 plus 169, which is equal to 106, the square root of 169, which is just equal to 13. And as we did on our graph, the distance between the 2 points is just 13 units. So I hope you guys understood how to find the distance using the distance formula, and comment down below if you have any questions.